Hello friends, today we are going to see DAC using R-2R ladder network experiment. Okay, so we all are familiar with the DAC, that means digital to analog converter using R-2R ladder network. Okay, the another type of DAC was binary weighted resistive network. Then in this experiment we just observe here the aim, that means to study the performance of a 4-bit binary ladder and determine its resolution and linearity. So resolution and linearity is one of the characteristic, or we can say the parameters of a DAC. Then in apparatus we are going to see here the R2R network kit, then digital multimeter, connecting wires, etc. Okay, so you can observe here the circuit diagram of a R2R ladder network. Why this is called as R2R ladder network? Because here only the values of registers is 2. Okay, consider here the combination of R series in series and the 2R in parallel. Okay, so output this is connected to this is nothing but the inverting terminal of op-amp, and the non-inverting terminal of op-amp is connected to ground. Then output is connected with the feedback of, that means we can say here this inverting terminal feedback through this feedback resistance RF. Okay, in today's experiment let us connect the circuit board using this diagram. Okay, so this is our circuit board, 4-bit DAC using R2R ladder network. In this plus VCC to plus VCC, then ground to ground, we need to connect this ground and this ground terminal also, then minus VCC here, and then output of this R2R ladder is connected to the one of the terminal of this op-amp. Okay, so here V0, again this analog output is connected with the input of this op-amp here. So minus VCC is connected, then ground is connected, then this plus VCC also connected, then output of this R2R ladder is connected to the one of the input of this op-amp, and the DMM is connected to the output of this op-amp. Another terminal of DMM is connected to this negative terminal, that means we can say ground terminal. Okay, so what happen exactly when we apply, according to the theory of DAC, when you apply the different digital inputs, we can easily observe the analog output. Okay, so according to our observation table, here is the digital inputs, then here is analog output voltage with calculation, then here with experiment, and here is the difference, or we can say error. So how to find out the analog output voltage using the formula? So let us see this formula. V out, which is equal to V reference D0 2 raised to 0 plus D1 2 raised to 1 plus D2 2 raised to 2 divided by 2 raised to n. Okay, so accordingly we have to give the value of V reference. Okay, so given value of V reference may be 5 volt, maybe 10 volt, maybe 12 volt, and then the how many number of bits you want to apply, and you observe the analog output. Accordingly you can D0, D1, D2, D3, etc. is your digital inputs. Okay, so let us see how it works. Initially all the digital input become 0 0 0 0. So you can observe this switch, this is 0, here is 1. So D0, D1, D2, D3. So according to our table, this is D0, D1, D2, D3. So the D0 position is LSB and D3 position is MSB. So accordingly, okay, after application of 0 0 0 0, you will observe the output on DMM is 0.0 volt. Okay, so that means when the input is binary 0 0 0, you can observe the output voltage is 0. After application of next 0 0 0 1, then you can easily observe half the change. Then 0 0 1 0. So output is like this. Accordingly, when you increase the voltage, or when you increase the, or when you change the digital input like 0 0 0 0 0 0 0 1 up to 1 1 1 1. So let's see the final output is 1111. So here is the full scale voltage 4.69 volt. Okay, so according to this table, okay, after putting the values of this 0001 digital input into the given formula, you can calculate here the values like this. Okay, and then this is the expected analog output which was seen in our digital multimeter. Okay, so this is what exactly the readings we have to read. Okay, then after plotting the graph, okay, so digital inputs are on x-axis and the analog output are on y-axis. After drawing or after putting this points, okay, we can say here the linear. Okay, so linearity parameter is there. Okay, after calculating the slope of that graph, we will observe here the value is what, 0.3 volt per bit. So this is nothing but the resolution. Okay, graphical representation of resolution. Similarly, we can also calculate the resolution by using this formula VFS divided by 2 raised to n. So here by calculation you can observe here resolution is 0.3 volt, and by graph you can observe 0.3 volt is your resolution. Okay, so this is our DAC using R-2R ladder network. Thank you, students.